All right, hey everybody, it's time to learn about some special quadrilaterals, or should I say parallelograms. Um, don't ask about my shirt. Long story, but I had to borrow someone's. Anyway, let's get to this. Rectangles, rhombuses, and squares are all special types of quadrilaterals, but more specifically, they're special types of parallelograms. So, because they're parallelograms, they have all the qualities that parallelograms have. Opposite sides are congruent, opposite angles are congruent, diagonals bisect each other, opposite sides are parallel, consecutive angles are supplementary. All of those things that we learned about parallelograms, rectangles, rhombuses, and squares have. In addition to those qualities, there's a couple of other things that we need to note. Rectangles have 4 right angles, which I don't think is surprising to anybody. I think that's something you've known for a while. But you may not have known that the diagonals of rectangles are congruent. So in this case right here, segment AC is congruent with segment BD because those are diagonals of a rectangle. So these two properties right here, you need to know about rectangles. Okay? So also note that because the diagonals are congruent and the diagonals bisect each other, then each of these pieces, then AE, EB, EC, ED, those are all congruent pieces. That only happens with rectangles, that all of the pieces are congruent of the diagonals. It's also worth noting about what happens if you make just one diagonal. You end up with 2 congruent right triangles. If you throw in both diagonals, you end up with diagonals, or you end up with isosceles triangles here. So isosceles triangles, right triangles, keep those things in mind with respect to diagonals. If you have one right angle in a parallelogram, then all 4 of the angles have to be right angles. That's using some of the parallel rules, but if one of these angles is a right angle, this parallelogram, all of them are. So that's rectangles. On to rhombuses. Rhombuses, the definition of a rhombus is it's a parallelogram that has 4 congruent sides. Okay? So if you have a parallelogram, 4 congruent sides, it's a rhombus. The other 2 qualities of a rhombus that you'll need to learn have to do with the diagonals. The first one is here. The diagonals are perpendicular. So if you have 2 diagonals within a rhombus, you will absolutely have right angles in the middle. Okay? Rhombuses, right angles in the middle. Also, the diagonals bisect the angles. Talking about the angles of the rhombus, the big angles here. So once you create diagonals, then all of these angles are being congruent. So that not only are the angles opposite of the big rhombus congruent, but all of the little angles are going to be congruent as well due to the angle bisectors. Okay? It's also worth noting about what a single diagonal will do here. It creates isosceles triangles, congruent isosceles triangles, and then 2 of them will create 4 congruent right triangles. Okay? But the 3 main qualities here are the things that you absolutely need to know about a rhombus. Squares are ones that you know mostly about. Squares are the simplest quadrilateral and they're the most complex. Here's what I mean by that. Squares are parallelograms that are also rectangles and rhombuses. So they have all of the qualities that are above, all the qualities of a parallelogram, rectangle, and a rhombus a square has. That's what I mean by them being the most complex. But they're the most simple as well. So the congruent sides, right angles, because all of the angles end up being 45 degrees. Whether you have a single diagonal or 2 diagonals, all of the angles are going to either be 90 degrees because it's a rhombus. We have 90-degree angles here in the middle because a single diagonal would make 90-degree angles and then 45-degree angles here. So every angle is either 90 degrees or 45 degrees, which makes it pretty simple in that regard. We'd be remiss if we didn't talk about a kite, but we're not going to do much with kites. A kite is the one thing here that's not a parallelogram. It has two congruent pairs of sides and has diagonals that are perpendicular. I don't plan on asking you a lot of questions about a kite, but it's worth just mentioning since I'm talking about quadrilaterals. You will, however, see questions about this related theorem. The actual theorem itself seems like a mouthful at first. The midpoint of the hypotenuse, which in this diagram over here, here's our hypotenuse, the side opposite the right angle. X is a midpoint, all right? The midpoint of the hypotenuse of a right triangle is equidistant from the three vertices. It's equidistant from A and C, which of course is equidistant from A and C because X is a midpoint, but what also is this equidistant from the other midpoint, in this case, or the other vertex, which is B. This has a name. It's called a median, right? So in this case right here, we have the AX is equal to XC, which is also equal to BX. All three of those lengths are the same. Do you remember what we call the segment that goes from the right angle to the midpoint of the other side? Or not from the right angle, but from the opposite angle to the midpoint? We call that a median. All right, so we're talking about the median from the right angle of a right triangle, that we end up with congruent segments. Here's the reason why. One right triangle is half of a rectangle. So BX is really just half of a diagonal when it's cut across there. All right, so AX equals XC equals BX. And the key thing here, the thing you have to know, is that you end up with all those congruent segments when you have half of a rectangle or a right triangle with a median drawn. Okay? Now, the types of questions that you're going to be asked mostly have to do with lengths of segments and angle measures. Let's look at this first one here. Find the angle measures of 1, 2, 3, and 4. Well, we first need to figure out what type of quadrilateral this is. 4 congruent sides here. We have a rhombus. Now, if we have a rhombus, the thing to note is that this triangle, the one on the right and the one on the left, which are congruent, is an isosceles triangle. We have these two congruent pieces here. Because it's an isosceles triangle, if we know that this angle here is 54, this angle over here, angle 3, is also 54. Then if this is 54 and this is 54, we can figure out what angle 4 is as well. Okay, 72 degrees. Then the congruent, or the triangle on the left, is congruent to the triangle on the right. So angle 3 is congruent to angle 2, 54 degrees. Angle 1 is congruent to angle 4, 72 degrees, opposite angles of the parallelogram. Okay? So that's one way of working your way around these types of rhombuses that has a single diagonal. Let's look at number 2. What quality do you notice that's given? Do you see the right angle here? So this is which type? A rectangle. So a rectangle, the thing that's going to be key about this is that we got right angles up in each of the corners, of course, and then we have congruent pieces here. The diagonals bisect each other and they're congruent. That is a key part of rectangles, which means every single one of these triangles is an isosceles triangle, and we have complementary angles all over the place right here. So if we know that this is angle 18 over here, that angle 18 is going to be equal to angle 3 down here because of alternate interior angles. It's also going to be equal to this angle that's up in the top right-hand corner and the bottom left-hand corner because of the isosceles triangles that were created. So we have 18 degrees all over the place. Then we can figure out angle, well, we could figure out angle 1 because we have complementary angles. We could figure out angle 4 because of the triangle property, 180 degrees. And then, well, if this is 72 degrees, then this is 72 degrees. We can figure out angle 2, or if we know angle 4, those are supplementary. There ends up being a bunch of different ways you can work your way around these guys. All right, let me get you started here on number 3. Pretty similar. this is a rectangle. Notice the right angle up there, which means we have all of these isosceles triangles and we have congruent angles everywhere. So the angle measure that's given here is 106. So here in the middle we have vertical angles and linear pairs, so we can figure out those angles there in the middle. And then we have isosceles triangles to get to the outside. Okay, so see if you can figure out why these are the answers. Okay. Number 4 is what type of quadrilateral? It is a rhombus with all the congruent sides. So because it's a rhombus, we have right angles here in the middle. These angles on the opposite sides are going to be congruent. The angles bisect each other. See if you can figure out angles 1, 2, 3, and 4. 59 degrees and 50 degrees or 90 degrees are what all those angles are. We could have figured out what these over here are as well if we tried to. This one, it doesn't tell us what these are yet, but if this is 30 degrees and this is 60 degrees, if that's 30 degrees, this is angle 2 has to be also 30 degrees. So what do we have here? 60 degrees, 30 degrees? That's a right angle. See if you can figure out the rest of those. And while you're at it, do number 6. Okay, those are the angle measures. Did you remember the right angle in the middle? Congruent angles that are opposite here with the bisectors. All right, the next type of question ends up being really simple if you do what I'm about to tell you to do. This tells you that this is a rectangle and it gives you the lengths of some segments here. Draw the rectangle. Okay? And it's asking, this question is about the diagonals of a rectangle. So what's true about HJ and KI, or IK? They're congruent because it's a rectangle. So all you got to do with all of these here is set those suckers congruent, solve for X. Go ahead and give that a shot. Pause the video if you didn't. Okay. These are the answers. And do me a favor and just over here on the right hand side or over here, just write LMNOP for me. I think that would be a great name for a band, by the way, LMNOP. I digress. I just want to make sure people are paying attention. All right, last type of question has to do with that median from a right triangle business. We have a right triangle, QS is a median. Do you remember what was true about that? Do you remember that we have congruent segments all over the place? And something I didn't do a very good job of explaining a minute ago was that what type of triangle then is QSR and QST? Both of these triangles are going to be isosceles triangles. What ends up happening if you know one of these angles? You know all of them, just like you can with a rectangle. Remember, this is half of a rectangle. So see if you can figure out how to answer these questions over here based on that. You're going to use isosceles triangle properties mostly here for 19, 20, and 21. Give it a shot. Okay, if this is 65 degrees up here, how do you find RQS? Supplementary angles. You may have questions. In fact, I expect that many of you do, but write them down so that you can ask me. Come see me and get some rest.